Hello all, let's start the second part of 7.8. 7.8 was about improper integrals. Let's start the second part of the lecture. Type 2. In type 2, we are dealing with discontinuous integrants. What does it mean when we are dealing with discontinuous integrand? Look, I'll draw 3 graphs here for you and I'll explain everything for you. For example, I have a function f of x, something like this maybe. Here, maybe I have a vertical asymptote. This point is A. Now I want to find the area under this graph. You see my function has a vertical asymptote and the graph is going to infinity here. I cannot touch the asymptote, and if I want to find, there is another point here, B. Let's name this one B. If I want to find the area under this curve, or if I want to find the integral of this function, one side is discontinuous. I'm not dealing with a closed interval. How to deal with this? I will choose a point like you learned in part 1. I'll choose a point, maybe I'll name it C, correct? And I will find my integral. For example, if it's given as an integral of A to B, f of x dx, then what I do here, I'll take the limit and I'll take my integral. Because I cannot reach to B, I'll start from A. Actually, B is the vertical asymptote. I'll start from A. I'll name it to C. Even in your book, they name it D or C. It doesn't matter. What do you name? F of x dx. The important part is that C is approaching. You see, your C is approaching to B from the left. That's the important. Sometimes you are approaching from the right, sometimes you're approaching from the left. Then I'll put my limit, but my C is approaching to B, not this time infinity, to B, to this point. From which side? From left side, correct? Or if I show you this graph, another one, because all of them is one case, all of these graphs. I have, for example, something maybe like this, and here I have another vertical asymptote. If I name this point A, this point B, and if I name this vertical asymptote A, if I have an integral f of x dx from A to B, to find this integral, you see A is the vertical asymptote. I'll name A C. I will take the limit. C approaching to A this time. If I choose a point here, for example, C is approaching to A from which side? From right side. Approaching to A from the right, integral C to B f of x dx. This two cases really important. The last case is maybe you end up from both sides. You have two sides of the function that they're going close to their vertical asymptote. For example, if I draw maybe a graph like this for you, this is my vertical asymptote. One side of the graph is coming this way, the other side is coming this way. At this point, I'll name it C, and here I have B, here I have A. Then how to deal with this integral? You do actually the limit of integral of f of x dx, correct? C is approaching to A from the right, here from C to B, plus the other part, limit integral from here A to C. C is approaching, C is approaching plus integral from C to B f of x dx. I will not put here limit for time being, because later I will explain for you how to deal with this part. And actually you will learn in case 1 and case 2 how to deal with this part. You are dealing with two integrals in this case, and you are adding at the end those areas. Now I'll do a numeric example. Numeric examples, maybe this explanation gets a little bit difficult for you, but in a numeric example, easily you can understand how to deal with these problems and where is the discontinuity, right? For example, if I asked you to evaluate integral from 0 to 9, 1 over a square root of x dx. How to know that you have a discontinuity? You see the domain of square root of x, 1 over square root of x. If you remember your algebra, you have a square root of x in the denominator, correct? Now you have to put your x greater equal to 0 to find the restriction. It means your domain greater than 0. It means your domain starts a number greater than 0, any number greater than 0, for example, from 1 to where? To infinity. If you plug in 0 here in the denominator, you see your fraction becomes undefined. Then your function is discontinuous at 0. And if I show you the graph is maybe something like this. At 0, you have your vertical asymptote. This is the point that you have it here as a lower limit. You have to change this one. Then your graph, you choose a point here, C, but your C is moving towards 0 from which side? From right side. Then I will rewrite this problem as a limit, C approaching to 0 from right, integral, wherever you have, which limit is discontinuous, change it to C, from C to 9, 1 over square root of x dx. From here on, I think each one of you, you know how to solve this problem, correct? How to find the integral of square 1 over square root of x. Now limit, C approaching to 0 from the right, integral from C to 9. Instead of 1 over x, you can write 1 over square x to the power of 1/2 dx. Now move the x up, limit, C is approaching to 0 from the right, integral from C to 9. Here you can write x to the power of -1/2 dx. Now you know how to find the integral of x to the power of -1/2. You add 1 to the exponent, divide by the new exponent, that's your integral. It means you will end up with, if you add 1 to the exponent, -1/2 plus 1 gives you 1/2. That means limit x to the power of 1/2 over new exponent 1/2 dx as c approaching to 0 from the right. Or if you simplify this, please put the bound from c to 9. No more dx, we took the integral, put the bound. From here, if you simplify, it will be limit 2x to the power of 1/2, or you can write 2 square root of x as c approaching to 0 from the right. From where to where? From c to 9. Now plug in the upper limit, plug in the lower limit. This one will be limit of 2 radical 9 minus 2 radical c as c approaching to 0 from the right. If you plug in here c, 0, square root of 0 is 0, 0 times 2, 0, this part becomes 0. Square root of 9 is 3, 3 times 2 is 6. It means your answer is what? 6. It means the area under the curve of 1 over square root of x from 0 to 9 is actually how much? 6. Correct? Let me do another example also for you. Integral from 2 to 5, 1 over square root of x minus 2 dx. First, you have to find your discontinuity. At this point, at which point you have discontinuity. To do that, find the restriction. You learned it from algebra. It means you have, take this under the radical, which is x minus 2, and it should be greater than 0, correct? Because your denominator cannot be 0. Then solve this inequality. If you solve this inequality, you move 2 to the other side. That means x greater than 2. Then what is the domain? The domain starts from 2 to infinity. But you cannot take 2. You see, I'm using parentheses here. It means you have a discontinuity at 2. Whatever the shape of the graph is, you get something like this. This is 2. This will be the shape of the graph, correct? Here is maybe 5. You want to find the area of the curve at this given point, but 2 is discontinuous. What you do, you choose another point here, C. C should approach, take the limit, C is approaching to 2. You see clearly in the graph, that's why I'm graphing to show it for you. From which side you are approaching to 2? You are approaching to 2 from the right, correct? Then rewrite the problem, limit, as C approaching to 2 from the right, integral, whatever the discontinuous is, 2 is discontinuous, at 2 the function is discontinuous, name it C, to 5, integral of 1 over square root of x minus 2 dx. Correct? Of course, you will use the substitution method here because you see the derivative of inside is outside. I will not show the substitution and again to you. You can practice that part at home. Now you can write this one as a limit. And if you take this integral, it gives you 2 radical x minus 2 from c to 5 when your c is approaching to 2 from the right. Correct? Of course, you name u x minus 2, then du equals, if u is x minus 2, du equals what? dx. You see 1 dx here? You do substitution at home. You can do 2 more steps here. Then you reach to my answer. You have this practice now. Now plug in the upper limit and plug in the lower limit. Then this one will be limit as c approaching to 2 from the right. 2 square root of 5 minus 2 minus 2 square root of c minus 2. If you plug 2 here, 2 minus 2 is 0, 0 times 2 is 0. This part becomes 0. 5 minus 2 is 3. That means your answer is 2 radical what? 3. Correct? This was the case 2 or the second part of 7.8. The important part, again, I'm reviewing here. The important is how to choose C and from what side you are approaching to C. If you have A and you have a discontinuity at B, you choose C close to B. When you take the limit, your C is approaching to B, correct? But from which side? From the left side. If your function is discontinuous at A, then you are approaching to A from the right, correct? That's the important part about this lecture. That was all about 7.8. 7.8, there is another theory which we call it the comparison test for improper integrals. Because it's a short-term course, I will avoid to teach you that. But at the end of the semester, for those of you that you are interested to know what is the comparison test for improper integrals, I'll make another extra video and I'll leave it there, but that part is not included in your test. We are done with this section, 7.8. I will stop the lecture here and see you next time for chapter 8.